Most of the charts that we build in production for data visualization are time series charts. They're line charts, stacked area charts, things like that, followed up by other traditional charts like bar charts and scatter plots. So I've got this pen open on CodePen. I'm going to put that also in the chat in case you want to open that, follow along from there. And it's very little code if you're looking at this. All we've got is I'm importing XYFrame from the sort of fixed semiotic resource. For those of you who are familiar with CodePen, you can go into your settings and you can point to this distribution through unpackage, and then semiotic will be exposed in your pen. And then I'm also linking directly to a repo where I had some data, in this case Premier League data, that I've cleaned up a little bit, that has stats for English Premier League teams over the last almost 100 years. Actually more than 100 years, but with gaps, so it totals up to less than 100 years, but it goes back farther than 100 years. If we want, we can take a look at what that data looks like. It's an array of 69 objects. For those of you familiar with English Premier League, even me, I'm not familiar with it, and a lot of these are familiar names to me. You have the team name, you have the first year that it shows up in the data set, and then you have an array of coordinates, and this is the data format that XYFrame expects. You can pass it parameters to point to different properties for your line chart coordinates. But it expects these coordinates, and in this case what I have is for each year that there was data, I have a few statistics about the team and the year for that data point. For some years when there was no data, I have just an object with empty values in the statistics that I plan on looking at. I have a property missing equals true, and year equals 1962, and we'll see why I built a data point for years that we don't have data. You'll also see, because of how this data set was built, that even though it goes back to 1888, it's pretty sparse early on. So what we'll probably end up doing is just looking at 1959 and onward, where there aren't gaps in the data. Or we could look at, periods where there aren't gaps in the data. So 1936 through 38, but that seems like a pretty short period. So that's what the data looks like. Let's see how we can get that into an XYFrame. An XYFrame is designed to deploy XY style data visualization. That's what it means. It's an information model that implies that you're interested in comparing a range of values by a range of values. And typically for time series data in line charts, our X range is some kind of temporal data. So in this case, years. And years could also just be position, days since launch, or just some kind of arbitrary number representing how things change, right? System clock, things like that. So an XYFrame takes data as points or lines or areas. We saw in an earlier example that I will pull up just so you guys can have more examples. On CodePen, I've got my front page, which again I'll just drop in the chat. And one of these examples that I looked at in a live stream was this scatterplot basics, where we ended up building a scatterplot with contours from this same data, this time looking at, I believe, I believe it's Everton in red, and I think Manchester United in blue. So that example also uses an XYFrame. It uses an XYFrame to present scatterplot data. The contours are area data. You can go take a look at that if you want to see how that's built. But to get back to our original example, we're going to be doing a line chart. So that kind of data is sent to the lines property of an XYFrame. So we send that premier lines data. And then we have to tell it, well, what is our x value? So our x accessor indicates the function that would return the x value, or if it's just a property name, you can send it a string with the property name. So in this case, it's year, I believe. If we look at the data, yeah. So here is in our object, we have a property called year that we're going to plot along the x-axis. And then we say a y-accessor. And the y-accessor in this case is going to be let's look at points. So PTS. And that should give us a line chart that if we go and change the line style value, should be able to see. It's probably important to see things, right? So line style is how you modify the styling that's sent to the individual lines that we're looking at. And it can take an object, or it could take a function, and that returns an object based on the properties of the line. In this case, we'll start out with just an object, and remember that object is a JSX style object, so it has to have the camel case style properties that you're going to be setting in JSX. So for instance, if we wanted to say stroke width, it would be stroke capital W to change the stroke width to 2. Now by default, all frames have a size of 500 by 500 pixels. We can change that to be, say, 1000 by 500 so we can see it a little bit better. We could make it smaller so it fits within this very constrained view here. I mentioned earlier that there's a data accessor. So you can sit here and say line data accessor. By default, that line data accessor is looking for a coordinates property. And that coordinates property is going to return that array of data that allows you to draw lines with an XYFrame. You can, however, pass it a function. And in this case, we could pass it a function that says that returns d.coordinates.filter and filter the coordinates so that we only get coordinates after that have a year value greater than 1959, I think greater than or equal to 1959. And that gives us back data without that mess of data pre-1959 that wasn't going to be useful for us to deal with. Let's only look at a couple of, let's go and filter premier lines. So we're only looking at a few teams to begin with before we start to get overwhelmed by trying to deal with 69 teams. So const top teams. I don't know that these are really the top teams, but we'll say that actually there's a way, hold on a second. There's a simple way for me to figure out which teams are the top teams, which teams have the most points, at least over this entire range. And I might as well show you how to do that, because you might want to do that at some point. So first things first, we'll say, we'll change this fill to red and a fill opacity to 0.5. You might say, well, why do I want to set a fill for a line chart? Well, that's because I'm going to change the line type from line, which is what its default is, stacked area. The stacked area chart will return, he says, oh, right, this isn't an object. I guess I have to do that. And a stacked area chart returns all of our properties. Now remember, this isn't good data visualization. I'm not claiming this is good data visualization, so bear with me. But the order by default in an XYFrame of the values in a stacked area chart is to put the lines, or in this case bands, with the highest aggregate values near the bottom. So if I turn on hover annotation, oh, that's interesting. So if I turn on hover annotation, I said hover annotation equals true, then when I hover over this, I'll be able to interrogate these individual points, which is telling me the x and y data by default, which is great. But I don't really want the x and y data. What I actually want, and I can get at this by setting tooltip content. Tooltip content takes an array, takes a function, and that function returns JSX HTML. Let's set the class name equal to tooltip content, because I've already defined some CSS rules for that div class. And in tooltip content, I will return d dot, what's it called? I think we want d dot team. We'll see if that works. So now when I hover over, nothing happens. What am I doing now? Let's see, I've got tooltip content, and for some reason I put that at the end of the tooltip content. Is that everything? Oh, okay. Well, there we go. My curly bracket somehow got lost along the way. So now when I hover over it, I can see which teams these are. And what's nice about this is I can go scroll down here, and I can see that Manchester United has the highest aggregate point value of the teams in here. Liverpool, Arsenal, Everton. It's funny, I've been making fun of Everton this whole time, and it turns out Everton is one of the top teams in here. All right, so I'm going to make a filtered array top teams equals premier lines top filter. Now you'll notice that I'm not using any kind of semiotic functionality. This is just something I've interrogated the data set. I've done some kind of data analysis, and I'm I'm filtering down the data set, or somehow otherwise pre-processing the data set based on the data analysis I've done. Semiotic doesn't do any kind of sort of automated data analysis for you. That's not its design. It's just, for data visualization. And I think that you'd want to use separate libraries for that. You don't want a single library that tries to do everything. They can be useful for sort of certain analytical purposes, but for the most part, like real analysis, real data science is done, with lots of different tools. So in this case, I'm going to say d.team. Let's see. We'll just make an array. Values like Arsenal, Manchester United, Everton, Liverpool, dot index of d dot team does not equal -1. And that should give me my top teams, or the top teams that I seem to look at. And sure enough, there we go. We've got Everton, Arsenal, Liverpool, and Manchester United. I can make this view a little bit longer so that it takes up more of my screen. Might as well take advantage of it. And I can get out of the stacked area chart for now, back to the line chart. I think I prefer that for now. We've got 4 teams. We can give those teams some different colors so we can start to compare the difference between them. And to do that, I'm just going to create a color object that's going to act as a hash. And I'm going to take a name of a team, and I'm going to assign it to one of these colors that I've already generated, just as a sort of early way to assign some colors to these values. I've toyed with the idea of automated coloring built into Semiotic. Frankly, it just doesn't seem like there's any good ways to do that. These 20 category color schemes that are so common with Tableau and D3 are optimized for 20 values. And when you just start to deploy them all the time, and you've only got 5 values or 6 values, then I think they do more harm than good, frankly. the amount of time it takes to assign some colors in a meaningful way is small enough amount of time to justify the effort. And I think you'll benefit from it immeasurably. So we'll take those colors, that array, and we'll pass it d.team, and that should give us a color for each. And sure enough, it does. So what I did was I changed this object into a function. So line style now is a function. It's going to take each of the line objects in the top team's array, and it's going to run this test on it, and it's going to return some kind of style object. You'll notice it still says fill equals red, but because these are lines, that fill's not showing up anywhere. And so we can look at Manchester United and Everton and so on. I think I'd like to get a couple more teams in here so that I can do a better job showing how to work with semiotic. I'm going to go back to a stacked area in that case, and then I'm going to go back to the original data set. I want to get some teams that have gaps. Now, Manchester United had one gap, but it didn't seem like enough in my mind. So I want to get, let's see, Tottenham Hotspur. So we'll add that one in. And we'll add one more, whatever the next one is up from Tottenham, Chelsea. And then we'll go back to top teams. And take a look now and see what it looks like. We can get out of the stacked area again. And apparently, only one of these is going to have a gap. And that's okay. That will still let me show off this functionality that I want to talk about. So when I'm hovering down here, you'll notice that the hover annotation is coming back with an empty hover content. And that might seem like it's some kind of bug with semiotic and it's broken. It's actually not. What's happened is I've told the tooltip content, come back with d.team. However, if you remember when we're looking at these actual data points, if I go into Manchester United, I guess I have to go all the way down because they're probably long gone. If I go into Manchester United, just somewhere in here. I'm sure this team exists somewhere in here. There we go. Nope, man. Boy. All right, there we go. Try this again. Let's see. If you go in and you look at some of these gap years, you'll notice that when I was filling those gaps, I didn't put a team name in there. So this is just tooltip content coming back with blank values, right? There's no team that corresponds to this function I said to provide it with some kind of hover behavior. Now, what's going on here is I have actual gaps in this data, and I don't want it to go down to that zero value. That zero value isn't a real value for points. It's just what I put into this empty piece of data. So two things. First, before we get into that, I think I want to add some axes to this. An axes is a property of XYFrame. It takes an array of objects. Those objects can have an orient, and that orient determines where the axis marks are placed. So orient left, orient bottom, and now we have an axis for our data visualization, so we can tell a little bit better what's going on with some of these teams where we have a lot of zero values that are just sort of floating around that have no IDs on them. And the reason they don't is because what that represents is it represents an undefined point in your line for your line chart. XYFrame doesn't realize that, so you have to tell it. You say, I have undefined points. And undefined points are actually defined in reverse. You tell it which points are defined. So it's going to examine a point, and you're going to give it some kind of test. And you want it to say, well, it's all of the points that don't have a missing equals true, right? So all of the points that don't have a not d.missing. And what does it do? It takes those gaps now and it doesn't connect them across. It doesn't drop them down to zero. And now you've got gaps in your data, which you should have. right? That reflects the actual data. I'll make the stroke a little bit thicker so we can see that at home. But that's exactly what you want. You want it to have a gap when presumably Manchester United wasn't in Premier League. That's my only guess. Teams get demoted and promoted, as I understand it. I'm not an actual fan of English football, but that's how I understand it. So I'm going to assume that that's when they were demoted. And that kind of makes sense because you can see that they were on this sort of downward trend during this period. And so, that's how you tell it you have gaps in the data. What is going on with Chelsea? Oh, did I not give Chelsea? Is that why? Isn't that cute? Chelsea's not showing up because Chelsea doesn't have its own entry, and neither does Tottenham Hotspur. That's why I'm getting those weird floating points, those ghost points. Come, Chelsea. Join us on our map of soccer. And then Tottenham Hotspur. I would not be surprised if I just misspelled Tottenham Hotspur, right? This is the next one on the list. There we go. So now we see some more gaps, more gappy periods with our data set. All right. So now we've got fundamentally a line chart, right? It's a line chart that allows you to sort of check out these top teams. You can see there was this point when Chelsea came back, and I guess they left. And again, we can see the top teams. You can make out the top teams, but it's kind of hard. And so we could also look at this. We could experiment. And the whole point of XYFrame is that you get into these modes. And here we are looking at this time series data with a line chart. And that seems pretty good. But is it the most useful way to visualize this time series data? Well, I don't know. That's why it allows you to easily jump between the two. So we could look at the time series as a stacked area chart, which I think is much cleaner. You can see Manchester United sort of maintaining its position in the Premier League. You can see that Arsenal apparently never was out of the Premier League, even though it's sort of third when you give it the aggregate points over time. Then Everton, Tottenham, Chelsea. You can see these big gaps in Chelsea's time in the Premier League. Ranking is important, so we could actually use a bump area chart. Well, actually, we'll start with a bump line chart. Bump line chart is a particular kind of chart that looks at rank. So now we're seeing the rank of these individual teams. Sorted in such a way that you can see who the top teams are during a particular year, based on the number of points. Here we'll add points in here so we can actually make that out a little bit better. So d.team, and then we'll say points, d.points. That's how you build your tooltip. In fact, maybe what we'll do is we'll build a viz in a tooltip. That's a new feature in Tableau, which is actually a pretty straightforward feature in Semiotic. Because you can put any kind of JSX in here, which means you could put another XYFrame in there if you wanted to, right? So here's Tottenham Hotspur with 49 points, being ranked underneath Chelsea, being ranked underneath Liverpool, being ranked underneath whatever these other ones are. I'll add a little bit of margin. You can adjust the margin. So XYFrame frames in Semiotic try to give you some smart margins. You could give it, however, specific margins. So you could give it maybe a margin up on top to allow us to see those hover annotations. We still want that margin on the left because that's where we've got our axis, and we still want a margin on the bottom because that's where we have our other axis. So maybe we don't need it to be quite so big as the default gives us. Okay. So that's bump line. A bump area chart is sort of a mix of a bump line chart and a stacked area chart. So So what the bump area chart does is it puts teams on top if they're on top, but it still encodes the value of whatever value it is that you're looking at, in this case points, in the width of the band that represents that team. So you can see that Liverpool is on top, and you can see the change sort of in their value encoded in the width of that blue line that represents Liverpool. And bump area charts are wonderfully useful when there isn't much change, and they can become maddeningly messy, as this one does, when there's a lot of change. So bump area charts are very valuable, but sometimes, but only in certain circumstances, only with certain kinds of data. And so that's always a big challenge with developing your data visualization. Even though you have all of these methods available to you, some of them are only suitable in certain applications. And that's why Semiotic's built like it is, so that you can jump between them, so that you don't just sort of invest all this time and effort trying to encode a bump area chart, only to find out that this is one of the 75% of the time that it's not the right chart, and you really should have just used a simple stacked area chart. So this way you can just sort of quickly prototype and jump between them. So line type will take a string. Line type will also take an object. Most of these configurations do when they have more advanced configuration. They'll take an object of type equal to whatever it is that you have, so that you can pass other parameters to that object. Now there's a few parameters that are available, primarily interpolation. So let's go look at what I mean by interpolation. If we go into the Semiotic examples, which are going to be updated very soon with some cool new features. Let's go look at a negative stack chart. This is interesting. Maybe we'll try to do some negative data so we can see what's going on here. And isn't it interesting? I don't put the code. I left out the code. Why did I leave out the code? So let's go see what that looks like. Negative stacked chart. Here's the code for that. And you can see that I'm passing in an interpolator in the settings, right? Line type equals a type and an interpolator. And if I go do the same thing over in my example on CodePen, right? I can say interpolator. And in this case, because I'm doing this, I'm importing D3. It's got to be D3 dot, I think monotone curve basis, I think is one of them, right? And that'll do I think you don't instantiate, I think it's just that, yeah. So that's a basis curve, right? We've got another curve. They're called curves now. They used to be called interpolators. A cardinal interpolation, a monotone interpolation that preserves monotonicity on a certain axis. So monotone Y is very different than monotone X, and it makes those little squigglies. So monotonicity just means that it's going to stay in it's going to pass through the values that it should pass through, as long as those values are adjusting along the x-axis. So this is the curve that you would use going left to right. You would use monotone Y if it was going top to bottom or bottom to top. Cardinal, there's a great one. There's a great curve. I think it's called cat-mole-rom, but I never remember what it's called. And so as a result, I never use it. It's really one of those API fails, right? Where you have to go look it up every time. And that's frustrating. Maybe, even though the original calculation was called cat-mole-rom, maybe we could have given it a more user-friendly name. Find cat. How many cats are there on this page? Into catting. Help me read about cats. I mean, mole-rom. I mean, there's so many different ways you could have spelled this. Cat-mole. The M isn't capitalized. Rom is. Rom spelled with an O. Anyway. So there's a lot of curves. You can use these curves to adjust how your lines are being drawn, right? Curve step does a simple step interpolation, so it shifts position immediately. And step interpolations on a stacked area chart are just, a dream to engineers. I found that performance engineers, DevOps types, this is the chart they love, is a step interpolation on a stacked area chart. I have no idea, but you know, who understands those people anyway? Step has a couple of different settings. This is just more deep into D3. Like, do you want to do the step change after, before, or on the point of change? And that really is going to depend on the kind of data you're representing. Typically, you want to pick a before or after, because especially if you have gaps in your data. Because if you have gaps in your data, you're going to get these weird sort of half steps. They're going to look like half steps, like you see over here. Over in Chelsea in 1994, you can see that it has these half blocks, which are kind of confusing to readers. Problem is that, you know, a before and after makes it harder to see when the actual, you know, they have to understand what the, I'm sorry, let's see, step before is what I wanted. The challenge with the step before and step after is in reading it. Like, which one is it? Does Chelsea have 54 points in 1994? Or do they have, whatever, 50 points in 1994, or whatever this is? Now, the answer, of course, is given away by the fact that the hover annotation works. And the hover annotation understands area charts. But still, for readers looking at it without that hover annotation, it becomes more challenging to read because it's actually offset, right? It's happening before the actual axis point where that change occurs, whereas curve step itself happens on the axis point. Anyway, these are just sort of inside baseball data visualization points that don't necessarily have to do with semiotic, but because they're all exposed in semiotic relatively straightforwardly, these are things you'll have to keep in mind. As far as things that are in semiotic, one of the features that I'm really happy with is the implementation of annotations. So we could add some annotations to this chart. Annotations property takes an array. It's an array of objects. Those objects have a type. That type is one of several types that I'll point you to. Oops, semitendentious. I have no idea what that is. Anyway, I'm not going to try to figure out what semitendentious means, and I'm going to resist looking it up, which is saying a lot. Let's go to the wiki. The wiki has good documentation. It's going a little bit out of date, and I'm going to go in, along with fixing documentation elsewhere, I'm going to make the documentation on the wiki much better, I promise. If we go into the wiki, there's the API reference, and then there's some tutorials. And the tutorials have some things like how to use annotations. And this is going to explain in more detail anything that I can sort of say while I'm actually using this functionality. But basically, the way that it works is that different frames have different built-in annotations, which are represented as a string value for your annotation type. And then if you want to, you could send them your own React annotation. So this implements under the hood the React Annotation Framework by Susie Liu. And you can use that to do all sorts of fun annotations. So we could annotate, for instance, an x point, okay? So x meaning somewhere along the x-axis. It could have a label of 1994. And then it would have a value that somehow corresponds to our year set. You can see how I've actually pointed at it. You can't see me pointing, but you can see it over here on the top left. Annotations are evaluated based on the parameters that you've defined in your x-accessor and your y-accessor. So they have to have properties that correspond to the data that you're actually representing. So in this case, 1994. And sure enough, it puts an annotation that says when 1994 is. And to differentiate it from the axis, we can make it red. And I'm not going to get too far into how to adjust annotations and such. That's more has to do with learning how to use React Annotation, but it all under the hood, like I said, implements all of this React Annotation framework stuff that you can move your annotations around, and you could set this up procedurally. So you could identify, make it look the way that you want it to look. So you can put a simple X annotation or Y annotation. And if you want, you could actually use these annotations in your hover annotation. So when you pass hover annotation, so hover annotation, this tooltip with a circle, that's just a certain kind of annotation. It's called a frame hover annotation under the hood. If I sent an array of objects to hover annotation instead of just the Boolean true, I could have each of those objects have a type. I could have one of them be frame hover, so that I continue to get my wonderful frame hover. See? And then I could have another one be of type X annotation, right? We just looked at an X annotation. And you'll notice I don't put any other values on X because it inherits the values of whatever I'm hovering over. I could give it a label. That label could be this year, and color, right? Because these are values that it's not going to get from whatever I'm hovering over. And then I get that hover annotation while I'm hovering around and looking at things. And just like that pattern we were talking about before, instead of just taking an object, it'll take an array that returns an object, and that object could pass the actual year value. So sure enough, hey, why isn't it passing the direct year value? I feel like. Isn't that interesting? So something's not updating. It's doing it when it's hovering, and then it's losing it. I've got a circle way back there. So obviously React Annotation is doing something kind of strange under the hood. See if it's even reporting some kind of error. Text.split is not a function. Text.split is not a function at wrap text. Maybe to string. There we go. That's the problem. I was sending a number, and under the hood, it didn't know what to do with that number. You know, it's failing. But if I send it as a string, then it deals with it. Now, I still think that's a bug. I think it should have dealt with it just fine. If it was a number, you shouldn't have to think about whether or not you're sending numbers or strings, but that explains it. So now I've got this little annotation. I could change it to be other kinds of annotations. There's all sorts of fun annotations that are in here. But I think that there's other kinds of annotations that I'd like to look at besides that. So for instance, there's like an enclosure annotation. Oh, actually here, this is more what I wanted to explain. So if I want, I could annotate with React annotation, right? React annotation just means I'm going to write a custom annotation, and I'm going to give it some values that are like, let's say, 1980, terrible year, and points value 200, and then a label of, say, here's an annotation. Let's see if that works just fine. Right. So you can see that little gray annotation. Again, I'll make it red. Here's an annotation popping out in 1980 at points equals 200. And then if I said dy equals negative 50 and dx equals negative 50, that makes it a little more clear. I'm pointing at this point. Now, but what am I pointing at? I'm pointing at a certain point on the chart, right? I'm pointing at Tottenham Hotspur in 1980. But I'm really not pointing at Tottenham Hotspur in 1980. I'm really pointing at 200 points in 1980. And that just happens to be where Tottenham Hotspur is in this layout of the chart. If I change the chart from a stacked area chart to a line chart, then Tottenham Hotspur is no longer there. In fact, 200 points isn't even on screen anymore. And so my annotation is being rendered somewhere, 100 feet in the air. So really what you want to do, instead of passing, in this case, what we want to annotate is we want to annotate a particular year for a particular line. So for it to do that, for the annotations under the hood to do that, you have to give it some method of identifying your lines. So what's like a unique value I have in these lines that would allow me to distinguish them? And in this case, that's the team name. So I could tell XYFrame, I have a line ID accessor, And I could say, look for team. Now that doesn't do anything at first. Nothing's changed once I've added that. But what it allows me to do now is I can pull out for this React annotation, I can pull points out, and I could replace it with a team. And I should probably replace it with a team that was around that year. Let's see, who do I want? Manchester United, always Manchester United. Manchester United. And so now I've got my annotation pointed at a particular team. In fact, I'm avoiding typing Tottenham Hotspur, but that's because it's a long, silly name. But I should use that since that was my initial example. So now I'm actually pointing at Tottenham Hotspur in 1980. And if I adjust the way that the chart is arranged, right? If it's now a bump line chart that isn't even looking at value, it's just looking at rank, then I continue to point at that. If I interpolate it differently, if I interpolate a basis curve, that's probably a bad example because basis actually isn't passing through points. If I interpolate it with something that guarantees it's going to pass through points, that's a better example, right? If I change it to a stacked area where the value is an aggregate value, it's still pointing at Tottenham Hotspur. If I change it to a bump area where it's an aggregate value modified by rank, then it's still pointing at Tottenham Hotspur, right? And I think this is a very powerful bit of annotation functionality. Annotation framework itself is great, but its ability to annotate a particular point on a line at a particular x value is extremely important for effective data visualization. I'm going to go back to what I think is the most useful version of this. I'll change 1994 to everything's about Tottenham Hotspur. It's the year when Tottenham Hotspur wasn't in the league. Now, if anybody has any questions, I'm not sure how many people are following along. Probably not very many. I know this is not the most popular, amazing YouTube channel. If anyone has any questions, I'd be happy to dive into particular functionality. Otherwise, I think I'm going to stop there. I think that's a good example of how to build out functionality in an XYFrame. It deals with a few things, like how line data accessor can be used to constrain your data set to just a particular subset of your data, even after you've taken the initial data that you're passing to the lines property and you've created a subset of that. I've explained how to change the line style based on a function, so you can have specific line styles for specific lines or bands of data. Talked a little bit about how we can use line types to show different kinds of line charts, whether stacked area charts or line charts or bump charts. This general pattern of either sending a string or sending an object of type equal to that string, turning on hover annotation with true, or passing an array of different annotation types that you want to appear when hovering, how that array can take objects of certain types, or it can take functions that return objects when you need to have those annotations have dynamic content. Talked about how tooltip content is used to present, to create an array that determines what you present when you hover over a point of interest. Shown axes. One thing I didn't mention in axes that I try to point out is that these axes are fundamentally very similar to the D3 axes. They vary in a couple of ways, one of which is that they very easily allow you to just add labels into them. That'll need me to adjust the margin a little bit so you can see that label. Ooh. You can see that label a little bit more clearly, but now it says points, right? I could put years on the bottom, but that seems pretty straightforward. This defined functionality, which I think is an important aspect of XYFrames and that sort of XY information model. So this tells you how your data points, how do you determine whether or not your data points are defined. And so in this case, we set up a missing value to indicate that this is a missing data point. You might have other ways. You might have null values, and you could just test to see whether or not a particular value is null. So that way it's discarded from the data set. You have margin, and margin could be, you could simply not pass margin, in which case if you've got axes turned on and things like that, it tries to sensibly give you some margins. You could pass a number to margin, and that will just give you a pixel value around every edge. Or you could pass an object defining specifically the top, left, bottom, and right values to set up your margins. There's a line ID accessor that allows you to tell the frame how your line data, a unique value for each line data object that you could then use in the annotations so that you could create an annotation that had an XY position that was based on a Y value, but at the X position based on that Y value for a particular line ID. And that's a lot of functionality and pretty straightforward to get up and running and put together, so you can make charts and you can make these sort of straightforward diagrams. I think one of the challenges that I always have when building these charts is that I'm so interested in showing the functionality of the charts that I don't actually address a sort of domain question, right? I didn't go in here saying, well, I'm a big fan of Liverpool, let's see when Liverpool really gave it to Chelsea. And that would be, I'm thinking, a more useful approach, just to be very glib about that. One way to deal with that is if we look at, well, we can literally look at Everton and Arsenal. We could take Everton and Arsenal. There's one other line type, it's a difference chart, but the difference chart only works when you send it 2 values. You can't do a difference chart with greater than 2 values. So we will make a special data set called rival teams. It'll consist of Everton and Arsenal. We'll pass Everton and Arsenal into lines, rival teams. I'll adjust my Tottenham Hotspur note so that it points to, I don't know, Everton, the worst team in the league. Not really, apparently, that's what I've learned from my data analysis, not the worst team in the league. So Everton in 1980, I've got this nice little stack chart. If I wanted to, I could do a bump area chart, right? Which shows now I can see sort of when Everton has scored less than Arsenal and when Everton has scored more than Arsenal. But another way to do that, and I think a very effective way, is what's called a difference chart. The difference chart will keep the interpolator as a curved linear, because weird interpolations can really cause a mess with this. A difference chart colors the difference between the 2 comparison values such that when Arsenal is doing better than Everton, the difference between them is colored in Arsenal's color. And when Everton is doing better than Arsenal, the difference between them is colored in Everton's color. And this tells a really interesting story. It tells an interesting story about the continuous domination, regardless of how Arsenal is doing as a team. Since apparently 85, Everton has never done better, at least in points, than Arsenal. And in 1994, it seems like they almost did, as a result of Arsenal really dropping down from their earlier score. Right, they went from 71 down to 51, and in fact, they went up to 63, and Everton went up to 61. So there was one time when they almost got back to their glory days, But then Everton went in the toilet and continued to stay there throughout the 90s and 2000s, and they seem to be going back there recently. Whereas Arsenal has maintained a much higher level of performance, at least based on my naive assumption. One thing that you might think is misleading is that the points value only goes down to 40, and maybe that you might say, well, that you might want a zero baseline. So actually, what you can do is you can set the extent in XYFrame, and you can set that extent to be an array of two values. So you could say, I want this to be between 0 and 100. Or you could set it so that only one side of that array is defined, in which case it will assign the other side based on the max, and then it will tell you, it will set one side in the fixed manner that you want. So now we have a zero baseline, and it'll base the other one off of the data that you pass. Now I think what I want to do is I want to annotate this just ever so slightly. Because what do I want to say? I want to say, well, Everton really peaked in 1984, right? Peak Everton. And adjust my annotations a little bit. Pull it back just a little so it's not even touching it. Instead of 1984, we'll say the year Everton almost came back. It's almost sad. I wonder if there are any Everton fans left. And then looks like 2003 is peak Arsenal. 2003 peak Arsenal, and then we can adjust that to that. Probably use a very similar offsets. And now we've got this nice little difference chart showing the domination of one team by another over time. Let me bump things around. If you've watched any of my streams before, you know that after a while it just becomes this this experience where I'm starting to like adjust and adjust and adjust. I'm not going to do that. It's funny, the peak Arsenal and the peak Everton are almost, I mean, the peak Arsenal is also, it looks like the peak distance between these teams. I don't think peak Everton ever did better than Arsenal more than they did. But that's an interesting little chart. And let's keep in mind, it's an interesting little chart that showed up almost as an afterthought at the very end of this experience. So, to me, that's an exciting bit about Semiotic and XYFrame that allows you to sort of move around this information model until you settle on something that is meaningful and useful and valid, not only for yourself but for the audience you're designing it for your collaborators and your stakeholders. So I hope that was useful. Like I always like to say, if you have any specific questions for me, please feel free to reach out to me on Twitter or here on YouTube through the chat, or file an issue on GitHub, send me an email, however you want to get a hold of me. I'm always happy to hear feedback about the library, how I can, teach about it better, and just specific or general questions that you have about data visualization or D3 as well. Thanks for joining me. That's about going to do it for me, and I hope you have a good time.